All right, today we're going to do 11.7, angles of elevation and depression. This can tend to be a little tricky when you guys do it, so just kind of hang with me here. The most important thing here is to know that horizontal, you have to come up with a horizontal line and then the line of sight. Okay, so if somebody is looking up at something in the sky or something higher, then it's angle of elevation. If someone is looking down, then it's angle of depression. Okay, and that's from the horizon or horizontal, either from the ground or from the person's eyes. It depends on what the question says. Okay, it could be from the top of a building or a car. You just kind of have to read what it says, okay? But the point is if you're looking up, it's elevation. If you're looking down, it's depression. That's the most important part. Okay, we're just going to do 4 word problems here. Okay, so Marcus is flying a kite. He lets out 40 yards of string and anchors it to the ground. So right now we're dealing with the ground. Okay, so we have a little stake here and it's let out 40 yards of kite. So this is the 40. Okay, here's our kite that's being flown. This is why I'm a math teacher. I can't draw. Okay, so it's anchored to the ground. So he's not holding it anymore. It's anchored to the ground. He determines that the angle of elevation of the kite is 50. So remember, we have to have a horizon. And since it's anchored to the ground, the horizon or horizontal is on the ground. Okay, he's standing over here. Okay, in a few minutes we'll do one from the person. Okay, so this is our angle of elevation right here, which is 52 degrees. Okay, and we're dealing with triangles still, so you would make this triangle. This is a right triangle. Here's the kite, the string on the kite. Here's the kite. Okay, what is the height x of the kite from the ground? So it's asking that. Okay, the height from the ground. This is the actual string, but this is the height x. So then we go back to our trig, our SOHCAHTOA. Okay, we're given this 52 degrees. Okay, we're looking for opposite, and we're given hypotenuse. Okay, so we're going to use sine. Sine of 52 equals opposite over hypotenuse. Okay, so this is how you would set it up. And so remember, since this 40 is on the bottom, we have to multiply both sides by 40. Okay, so it becomes 40 sine of 52, which I believe is about 32. So 40 sine 52. Make sure I'm in degrees. Yes. So it's going to be 31, depending on what it asks you to round to, but 31.52, and we're dealing with yards. 31.52 yards, which makes sense because 40 should be biggest because it's the hypotenuse. Okay? Sorry, I'm having an allergy attack here. The next one. Felicia wants to determine the height of a tree. So we have a tree here, a red tree. Okay, and here's Felicia. Hi. Okay, Felicia wants to determine the height of a tree from her position 20 feet from the base of the tree. So she is 20 feet away. Okay, it actually should just be to right there. She's 20 feet away from the base of the tree. She sees the top of the tree at an angle of elevation of 73 degrees. So this is one of those ones where you have to go from her eyes. Horizon, this is the horizontal, so this is 20 feet away. And then she's looking up to the top of the tree. Okay? So this is our angle of elevation. This is the hardest part, is coming up with the drawing or the diagram to figure out where the angle of elevation is. Okay, the reason why it's not down here like it was in the last one is because it doesn't say the angle of elevation from the ground or from her feet. It says from her eyes. Okay? And it says Felicia's eyes are 5 feet above the from the ground. That'll come in handy because what we're going to find, we're going to make this a right angle here, and we're going to find this. Okay, so we know this, we're going to find this, and then we know what this, the rest of it is because it's 5 feet. Okay, so the information we're given from the 73 degrees is we're given the opposite and we're given the adjacent. So we're going to use tangent. So tangent of 73 equals x over 20. So again, from here we solve for x, we multiply by 20. Okay, so 20 tangent 73 is 65.42, we'll say, feet. Now that's what x is, but it wants the height of the whole tree. So then remember we have to add this 5 in there to come up with the rest. Okay, so plus 5, so 70.42 feet would be how tall the tree is. Okay, the next one, so these two are going to be angles of depressions. Okay, an airplane, so here's my awful drawing of an airplane. An airplane is flying 0.5 miles above the ground. Okay, so it is, let's say this is the ground. It should be straight, but you get the point. 0.5 miles above the ground. If the pilot must begin a 3-degree descent to an airport runway, okay, so here's the beginning of the runway. Okay, we'll say this is the runway over here. Okay, so again, we have to have our horizontal line and then our angle of descent to the beginning of the runway, and it says it's 3 degrees, so it would be really a lot smaller than that, but for the sake of the picture. How far is the airplane from the beginning of the runway? Okay, and it says in ground distance, okay? In ground distance. So that means like, what is this distance right here? Okay, this one gets a little tricky, but you have to really read what it's asking. Okay. Okay, well, if this is our degrees right here, okay, we really need to use this triangle. Okay, but this makes a nice rectangle. So if this is x, we know this is x. And if this is 0.5 right here, we can just bring it across and make it 0.5 right here. Okay, so we're coming up with this x right here. So we're from the 3, let me change my color. From the 3 degrees, we again have opposite and we have adjacent. So tangent of 3% of 3, let's just say 3, equals 0.5 over x. So this one we have to do a little bit more work on, remember. We have to multiply by x, so this would cancel. We have x tangent 3 equals 0.5. Then we have to divide by tangent 3. Okay. Oh, I'm looking on the wrong page of my notes. It was confusing me. Okay. So you should get 0.5 divided by tangent, whoops, and make sure you're in degrees. Again, I can't reiterate that enough. Okay, so you should get about 9.5 miles. 9.5, are we dealing with the miles? Yeah. Is what this distance is here, or this distance here would be the same. Okay. Last one. A building is 200 feet tall. So here's our building. It's 200 feet tall. The angle of descent from the top of the building, so remember we have to start with the horizontal, to the car, so here's my awesome car, is 25 degrees. Okay. How far away is the car from the base of the building? So again, we're looking for this. Well, let's do that. Which, remember, since we're dealing with right angles, it's the same as this. Now what you could do is subtract 90 minus 25, and you should get the same, an angle here, and you can do it that way. You should get the same answer. Let's try both. Okay, so if we're looking for this, and if this is 220 over here, it should be 220 over here. Okay, and we're given this 25 again. We're given the opposite and the adjacent. So it should be tangent again. Tangent of 25 equals 220 divided by x. Again, we got to multiply it by x. So x tangent of 25 equals 220. Divide by tangent of 25 because we want x by itself. Okay, so 200 divided by tangent of 25 equals 428.9 feet. Well, I'm assuming, are we doing feet or miles? Feet. Okay. Now let's see if it works the other way. If we did 90 minus 25, so let's say this is 65 degrees. Okay. So if we want to do this, we're given, again, opposite over adjacent. So we're going to do tangent of 65 equals x over 200, multiply by 200. So 200 tangent 65 equals, same thing, 428.9 feet. So either way, so you can use either triangle, you just have to, know your 90-degree angles and things like that. So perfect. Either one is fine. Here's a little comic, and we're done.